Oh, and you know what else I got, by the way? You're the first ones to experience this. I got a webcam light. All my selfies will be better now. No, I did. I got a webcam light because all this lighting is just bad. You know what I mean? I get like I'm kind of partially in the shadows. And now, as you can see, lit up and beautiful, just like normal. And so that's fantastic. Lighting is just bad. Isn't that better? Does that lighting seem better? And some of you, you're like, nah, about the same. Okay, you're still just, the man in darkness as far as we know. Uh, Drop in the link into the channel, into the text channel, and dropping it into the schedule like I do real quick. Hope you're okay with that little bit of overhead. Just kind of helps everybody if we do that. So appreciate your indulgence on that. I should try to get better at starting that earlier. But there we go. Oh, wait, isn't it gonna be like weird maybe like if we go back to in-person classes in the fall? I feel weird. Like it's been almost a year since we've been online. That's crazy, right? I don't know. Um, it just seems, oh, nice. The power planning. Thank you, Matt. Yeah, I don't know, right? I don't know. It's just like, okay, I gotta get in my car and drive to another place to talk to people. How barbaric, yeah. Um, I don't know. I like it either way. This has been great for me, honestly. It really has been fabulous, truly. Um, Although, here's the truth. Hang on, I got one. No, it's going to take too much time. I can't do it. I'll pop it up later. By the way, okay, quick updates on housekeeping. I am doing my happy surgery tomorrow. The major intrusive, you know, the spinal frontier. That's what I call it. So tomorrow is the spinal frontier to boldly go where I've never gone before. And then I will be out of commission on this Thursday and next Tuesday. And so what I'm planning to do, Walter and Zach will be on standby always, like they have been. I think the DMQ is working great from my perception, but if that's not true from your perspective, will you please let me know? Okay. Like, please, please, please let me know. I've got to know what's not working in order to calibrate. You know what I mean? And to make tweaks or adjustments or, you know what I'm saying? You got to let me know if stuff's not working. It's not whining. If you're like, if you swear at me while you do it, that's not appropriate. Um, if you're excess pissy, not super appropriate. That doesn't help. But letting me know, like, yo, Dr. K, whatever, I dropped a thing in the DMQ and I waited 48 hours. I really, really want to know that so we can adjust our system. Okay? Deal? Please, please let me know if there's problems. I'm not offended. I need to know if there are problems. But my perception is that it's working great. And my perception is that Walter and Zach are a dream team and just amazing and wonderful. That's my perception, but I want your feedback. Again, let me know. And if there's anything like more of a personal nature, DM me and let me know. Okay. Okay. So what I'm going to do today is I'm going to record um, I'm going to record the next two lectures today. And I'm just going to kind of like just go for an hour and 15 minutes, set the timer, go, stop. I can let you know on the chat. I can let you know on the chat server, on the general chat server, like when I'm going to do it, just in case anybody wants to be along, live in real time and be the studio audience. But it's no pressure. And if nobody shows up for studio audience, that is zero problem. Hold on a second. I just have to close that closet. It just bugs me. Okay, no pressure to be there one way or the other, and I'm fine doing it without. It has the advantage of probably I go faster because I'm not waiting for any responses, And the downside is it's less interactive, and I really love the in-person because you can do the interactive, pause, get everybody engaged. That's how I like to do it. So this is a little bit of a downer in that respect, but I'm going to do that. Maybe I'll stream to YouTube, or maybe I'll record it myself and post. If people, I don't know, I'm not sure, but I'll post when it's going to happen, just in case. I'll go ahead and stream it to YouTube. I might as well. There's no harm there. No harm, no foul. Okay, so here we go. If there any other housekeeping, um, yeah, man, 2810 marathon baby. And so Matthew, are you asking about this one or the ones that I'm going to do? Because the point of those is, in fact, to get them the next one. Yeah, absolutely. The point is to get those on YouTube. And ideally, I'll just do them as I do them. It's the cleanest way. The only overhead is I got to change the memes. I have to swap the memes out, right, as a matter of principle. And then they'll just be up there. And then the idea would be you can hit those at your own pace, but don't take the bait, okay? Um, don't listen to the sirens, that are going to drag the ship to the rocks that say Dr. K's unconscious and everything's out there. I can get to it whenever I want. And then a week goes by and you haven't touched it. And then you bail, you fail, and that's how it can happen. So that's the danger zone. And Zach's not here, so he can't drop any Kenny Loggins on me right now. But that is the danger zone, and you can't go there. So what I'm going to strongly recommend you do is at regular class time on Thursday, just, you know, budget that time, put it on your schedule, make an appointment with yourself, and then just watch the YouTube video at that time. And then if you have questions, pause, and drop it in the general chat. Anybody else who's there might be able to also help each other out a little bit, which I really love when you help each other. Answering questions. I've seen a lot of that actually in the general chat. I love it, love it, love it. Warms my heart, warms my crusty old heart. Okay, that good? So that's my recommendation is do that Thursday and then Tuesday. But if you're really gung ho, get after it, no sweat, and get ahead. That's fine too. Get all caught up. And then my expectation is that I'm going to be back in the game a week from Thursday. We shall see. One does not know for sure. Okay, let's go. Let's go. Ready, ready, go. Let's do some lecture factor. We are still talking about, and any other housekeeping, this is the time, okay? Always a little bit at the beginning to try to do some housekeeping, just to let people know kind of what's going on. Okay, whew. I do like the light. By the way, check it out. I've got the, I don't know what that is. This is like a bluer light. That one's like the warmer, and that one is the one that's like, let's take the white man with very white hair and make him look even whiter. That's this one. And this one is like, let's pretend that this white man has seen some sun somewhere in the last, several months, which is kind of not true, right? So this is it. It's the warm lighting. That's how I'm rolling, my friends. And then the other thing I got to play with is I can make it brighter, and I can make it, oops, that's on off, and I can make it dimmer. Gotta go brighter, gotta go brighter. Showtime, baby. Okay, let's do it. I'm going, this is the brightest setting of the warm color. Is that working? Calibrate me. Okay, I'm going. Here we go. We were talking, if you remember, we were talking about, yeah, purple and, yeah, Judelin, purple and blue for the win. Absolutely. Yeah, man, I got to work it. Okay, I'll see what I can do. You get that surreal, that dark purplish nighttime, Rock of the Vincent Price, you know, that's a back reference for some of you. Well, for almost all of you. Okay, we were just talking about like different ways of representing numbers, right? And you can do these different, we talked about different ways of representing it. And we ultimately decided, well, why am I going to do it like this? And the answer is that we've got to be able to manipulate it. I got to build machines, right? If I've got like wooden sticks and I'm just tallying sticks, go build a calculator. You know, how do you build an automatic calculator out of sticks? You know, or, you know, now if I do like strings and little threaded big beads, I can build a calculator called an abacus, right? Which is a manual calculator, and manual in the sense of hands, right? The word manual extends from the Latin root mano for hand. That's why manual labor is not men's labor, it's hand labor, okay? That's the Latin root. And so the manual calculator means you have to use your hands to go flippity flip, flip, flip. And they can, you know, the people that have that, it's very, very fast. It's remarkable actually how fast they can roll with that. But that's, you know, that's about it. That's a mechanical calculator that you can use by hand. But we're trying to build a digital machine. Remember, we're trying to build something using these discrete states of zeros and ones and build a calculating machine, a computing machine. Well, you got to have some system, and we already talked about, right, ones and zeros and kind of how we take a moving form and carve it up so it looks like, basically, it looks like that. 001. I'm talking technology. You know, 110. And so now what we're going to do is talk about just ways that I'm going to use these ones and zeros to represent integers. Okay. And I don't know if we talked about this yet or if it's coming up, but we're not going to talk about real numbers. We're not going to talk about fractions. We're not going to talk about scientific notation. You know what I mean? We're not going to talk about all of those different kinds of numbers. We're only talking about integers. And maybe that's ignoring a big part of the world of computing, right? Fine. Um, but this is where we have to start. And then later on, we'll touch oh so briefly on like, well, how would you represent a real number like a fraction? Well, we'll touch it, but we're not going to go there. The bulk of what you actually do in computer science, in programming, is actually integer arithmetic, right? Think about it. Every for loop is integer arithmetic, right? You start looping and counting, integer arithmetic. Every bit of counting, manipulating characters, all those kinds of things are integer arithmetic. So integers are very, very important. And integers, as a reminder, are the numbers that are positive and negative whole numbers. They're just numbers that don't have fractions. 5, 17, 21, you know, 0. These are all integers, and they are integer in the same root as integral or integrity, wholeness, right? No broken parts, nothing missing. They stand alone as a single thing with no fractions. It also means that they are kind of by their nature more or less discrete, right? I mean, everything falls into a discrete bucket. There's no 5.1, there's only 5. There's no 6.9, there's 7. You know what I mean? It's like everything has to fall into these nice chunks of integers, okay? So there's a discreteness to that idea. And we just ignore all the sort of continuous number systems, fractions, everything in between, okay? Rock and roll. I heard a quick bump on the mic, and maybe it was a temporary hot mic, and maybe it's gone now. Don't know, but just be aware. Watch your mics. Okay, ready? So the first thing we talk about is unsigned integers, and the idea here. So these are what technically the whole numbers, you know. But I always, to me, whole numbers and integers was always like confusing vernacular. You know what I mean? I thought the terminology as a kid was always like that's pretty arbitrary, since all the integers are kind of like whole and complete. Hang on a second. I got a hot mic on you, man. It's not really bad. It's just little bumpy sounds. Um, so heads up. Haste. Okay. Um, haste. Yo, haste. Haste. Hot mic, baby. Hot mic. Come on. Okay, unsigned integers. Here's the idea. There are no negative numbers. We're not even dealing with negative numbers right now. Just assume everything's positive, right? It's kind of what we've been doing. Right? Didn't we already say, oh, here's a bunch of zeros, 4 zeros. What's the smallest Yeah, I can mute him, but I don't know that it mutes him for you. I know it mutes him for me and for the audio. It's okay. It's okay. Man, we're gonna cancel. We're canceling Haste now. I'm gonna go ahead and mute him. And yeah, we don't want to make waste. You know what I'm saying? That is really what we're about here. Hang on. I'm gonna mute our friend. Okay, sorry, Haste. You've been muted. You've been muted by the admin. Okay. You know when we've done before, we're like, oh, look, 4 bits, right? We kind of go, hey, there's 4 bits. What's the smallest number? And we're like, well, when they're all off, 0, 0, 0, that's 0. Well, we both know that there's also like negative numbers out in the world, but we're just not dealing with that right now. We're just kind of going, that's our smallest number, 0. The smallest number is not negative something. No, right for now, it's just 0. And what's the biggest number? They're all on. So that would be 15, right? We went through all that. So with 8 bits, what are the smallest and largest possible unsigned? Unsigned. Every time, by the way, when we talk about this, and especially like on the exams, you've got to pay attention. I'm going to tell you what the data type is. Unsigned integers. If I say what's the largest possible unsigned integer, you got to pay attention. You just can't go, oh, integer blah and slop it. You can't, in a lot of areas of your life and even in classes, there's some classes where you can kind of slop it, and get your B minus and get out. In computer science, it's got to be right. It's sort of like it doesn't work until it's right. It's like 0 until it's functional. It's kind of a discreteness again, right? So what are the smallest and largest possible unsigned integer values if you got 8 bits? Well, the smallest is they're all off and the biggest is they're all on, right? Fantastic. Um, Now, this number right here, like, okay, 255, we walked through this, right? So this is in fact a 1 and a 2 and a 4, a 1 and a 1 and a 2 and suddenly I'm Lawrence Welk. 1 flashback, go look it up, Google that. 1 plus a 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128. And if you add those all up, you get 255. Also, if you look one more past it, and that's 256, the one we didn't quite get to, and you subtract 1 from that, it's also 255. Whichever way makes you happiest for calculating that, okay? Little interlude. You ever wonder why the world always numbers things with ones and us kind of CS nerds always start with 0? This is why. This really is, literally, this is why for us, it's always, we start counting from 0. I mean, we can still, when we're trying to figure out how many of something there are, like, okay, everybody raise your hand. We'll go 1, 2, because we're counting a quantity. But when we're like traversing or making our way through some list or whatever, we always start at 0 because 0 is the smallest number, in an unsigned integer. So that's why, just a little FYI. For your FYI. Okay, so that's unsigned. It's really, when I say unsigned, I'm really just saying everything we've kind of already been doing is unsigned integers. Okay, great. But as I said, we have to talk about signed integers, right? Negative numbers. How are we going to do subtraction if you don't have negative numbers, right? How are you going to do subtraction? We got to be able to do that. Without subtraction, we don't do division. There's just a lot of things you don't get to if you don't have negative numbers. Duh. Like representing negative quantities. So it turns out that that negative numbers are very useful. Newsflash, negative numbers, very useful. Okay, now there are, in computer science, there are many, many ways that have been attempted or tried or experimented with one time or another. But there are 3 classic ways of doing negative numbers in binary, okay? They are sign magnitude, and we're going to break these down, okay? We're going to break these down in great detail. Sign magnitude, 1's complement, and 2's complement. So 1's sign magnitude notation, 1's complement notation, 2's complement notation. Now it turns out that 1's complement turns out almost to be just like a historical side note. Little historical story that kind of shows up, inspires two's complement, and then goes away for the most part, okay? So really the only ones we're going to care about in the end really are sign, magnitude, and two's complement, okay? But here's the interesting thing with negative numbers, and you'll find out why this is. But with positive numbers, with unsigned integers, it doesn't really matter how many, how many bits you've got, right? I mean, it does, but I'm just saying, if it's like, oh, I got 4 bits, what's the smallest value? 0, and I grow and I can just kind of keep adding bits. It turns out with signed integers, I have to have a fixed number of bits, okay? Especially two's complement. The number of bits has to be known going in, okay? So a 16-bit two's complement number, a number that has been written in two's complement notation, you got to know like how many bits it is. And when you start to do operations, it matters. Unsigned, it doesn't matter. And we're going to figure out why that is, okay? Now, I want to talk about this. Do I have another one? Yeah. We're going to talk about, I'm going to use this term notation, okay? And I'm going to say the concept of ones and zeros in binary and base 2, those concepts are universal. We're going to apply those concepts no matter what we do. But when I say that numbers are represented in a particular notation, it just means that there's a social contract. Okay, now you're going to hear me say this word many, many times. Okay, all right. Are you etch this in, carve this into your retinas? Okay, I'm going to add a spontaneous slide right here for you. Okay, are you here? Social contract. Okay, what does that mean? It means, I'm sorry, for those that have just experienced motion sickness, I apologize. Social contract. Okay, how does the computer know? Some of you will ask me this. It's a great question. How does the computer know, like, whether that's a character or a value or a pixel or how does it know? Or a positive number or a negative number, how does it know? The answer, social contract. Okay, the bits are just bits. So the question is, how do you apply the social contract, right? What does anything mean? What does anything mean, right? What do these words mean that I'm saying? I'm speaking in English, broken English, and they mean what we all kind of agreed that they were going to mean. That's just social contract. So that's how we can communicate, is because we agree upon, the meanings of things. Okay. So everything we do from now on. Okay, sorry, I just saw the GIF. And yeah, I'm a sucker for Andy Bernard. Yeah, so what does it mean to represent something in a particular notation? It just means that when I say this, here's what it means. Or when I give you fingers in this configuration, here's what it means. Or right now, here's how we're going to treat something. Okay? It is the rules of the game. Okay? I know that's not making a lot of sense yet because we haven't anchored it down. We're going to get really concrete here in a second, okay? That's where we're heading, to concreteness. So if we say that all of the numbers that are going to be used in our adders, we're going to make an adder, something that takes 2 integers and adds them, right? Well, how's the adder going to work? What's its assumption? Well, it has to make some assumptions. Am I adding unsigned numbers? Are they possibly signed? Are they signed magnitude? Are they two's complement? What is the notation? What is the social contract? Okay. And based upon that, I'll build the adder based upon what I expect. Okay. So that's all. We design the hardware to treat it that way. And when we write programs, our programs act a certain way And that's how the computer knows whether, so the truth is the computer doesn't know. The context is built into, let me back up. There are some assumptions that our computer has to make down at the hardware level, okay? Like what are the numbers I'm adding? What's the notation for the numbers I'm adding? You have to know that at the hardware level. From a program's perspective, the numbers can literally just mean anything you want them to mean as long as your program acts like that and treats them that way. Okay? Hope that makes at least a little sense. Um, so, okay, let me see who said that. So Braden, no, you didn't miss it yet because all that. This is where we're going. We're going right now, Braden. So no worry. Um, unsigned means everything's positive. Signed means we have some way of representing negative numbers, and I haven't explained it yet. But there's got to be some way to treat this number like a negative number. That's what signed is. All will be revealed, okay? Anyway, one of the other themes that's going to show up is some of the design decisions have emerged because of the ease of building hardware to use it a certain way. Some of the core decisions get made, and you'll find out when we get to two's complement notation that certain things were easier when we just thought of negative numbers that way. And other things, you could think of it any way you wanted, but it was cumbersome. Okay? And all shall be revealed. And here we go. Social contract. I did have a slide, but this is a better slide because it's from the heart. It's spontaneous. Okay. The same set of bits can mean different things. Okay. The same set of bits can mean different things depending upon the social contract that we applied. Here's an example. Winston Churchill. What's the first one mean? Same man, same hand, same two fingers, both up. What's it mean? What's the left one mean? What's a respondos, please? Bueller. Ooh, someone's got really staggery. Someone's got really staggery audio. I don't know who that was. Um, yeah, exactly. The first one's victory. V for victory. That's V for victory. And in the UK, and as far as I can tell, yeah, it was like Satan. You know, it was like, right? You play it backwards, it's a message. Um, yeah, the first one and the second one means F you. Okay. What you're right, right? What makes the difference? Okay. Um, yeah, it also means, especially if you give it this, if you give it that, it does kind of mean, you know, up your arse, as the Brits would say. No, right? I mean, same symbols, different meaning, right? And this one, okay, in America, we had Richard Nixon, who was famous. I can't even do it. It's so ungodly nerdly the things he did back in the 70s. But he would put the V signs, and it would just go like it would just like this really. I don't know why it is anyway that elected officials have to be so awkward as humans. I don't know why that is. But in any case, there we go. There's Churchill. Okay, how about this one? Here's another one. Check this one out. This is this right here, right? Uh, Lower right, death metal. You know, yeah, right. That started with man, one of the founders of Dio actually, I think was the first one to ever do that. He tried to trademark it later. Like, okay, there we go, Nixon. Oh, thank you. Oh my gosh. Oh my gosh. I was alive and I remember this guy, and I remember as a teenager that this guy was like, okay, that's just really something. Thank you for the picture of Richard Nixon on that. Um, and I think that in the social contract with Nixon, it meant I am a criminal, I think is what it meant by social contract. Eventually, it got really no presidential candidate ever after was willing to, like do this thing. I don't know what it was. Okay, so that means I don't even know what it means. Satan horns or something. I don't know what it meant in the sort of heavy metal, death metal. I don't know anything about the band Dio other than the founders, the name escapes me, created this thing one day on stage and it caught on. And it became kind of like a rock and roll standard, right? Eventually, and sometimes giving way to this, which is ASL, American Sign Language, for I love you. That's cool. From the heart. I do love you. Okay, right here. What does it mean? That's the University of Texas. That's Mac Brown, uh, whose career was ruined by Taysom Hill and BYU. Turns out for local color. That's Hook'em Horns. That's Texas Longhorns, right? That's Longhorns, Texas. Okay, now this guy here is man. How do you say it? Berlusconi? He was the prime minister of Italy. Okay, in Italy, where I lived for a stretch, this is the horns. The horns. The man. I'm drawing a blank on. Uh, it basically means, may your spouse be sleeping with another person. You know what I mean? It's not really the bird, right? In America, we have the bird, which we've exported to the world, right? Everybody knows what that is. Um, but and then what you see, and the reason he's doing this with all these other people is it's almost like in Italy, if you do it seriously, then it is really, really bad. Okay, if you like literally just go, like that, and you're like waving it at somebody, then it's really like fu. It's really like the bird, right? Um, the finger, right? There are five fingers, but that's the finger right there. This is not the finger. Pinky, not the finger. That is the finger. Anyway, what they do in Italy is sometimes, you know how when you're like in a picture with your stupid buddies at spring break, and somebody wants to like put their fingers up behind you, like, you know what I mean? That's kind of like that's the joke, right? Well, in Italy, if you're joking around and it's kind of a little bit like locker room humor, people will go like that behind each other, like ha ha ha, and that's what Berlusconi is doing here, because whatever, prime minister, that's what you have to do to be prime minister. Okay, point I'm getting at. You know the point, right? You've got essentially a binary number. You have a 4-bit binary number, right? Which happens to be there's a one, there's no twos, there's no fours, and there's an eight. So you got the binary number nine, which, depending upon social contract, either means rock and roll or hook 'em horns, go Texas, go Longhorns, or uh, locker room fu, right? I mean, it just, depending on culture, those bits literally mean different things depending upon social contract, and they are the exact same representation. And to all of my Italian friends, I just want to apologize. This is not meant personally. Okay. Right? You got the idea? Same bits, different context, different meaning. And the reactions can be different. The way you treat it can be different. Okay? Everyone got that? And if you're Ute fans, you got that thing, right? Which is loosely a U, but the proportions are wrong. I'm sorry, Ute fans. That doesn't work for me. Um, what do we have? What do we have here when we're repping the V? By the way, can we start a trend? I'd like, BYU is the Y and the U of U is the U. Can we be the V? Can we just be the V? I like it. I usually will say when people like admire my UVU jacket, I'll say, man, you got to be repping the V. You always got to be repping the V. And I'll say, yeah, I teach at the V. I've actually started to do this for the last couple of years. And it's my experience that if you act like something's actually a word in the vocabulary somewhere, I've done this before. Like, I think the first time I did this was like 30 years ago, maybe more, maybe longer, where I started doing a thing that I completely made up. And then, like 2 years later, I was actually, now, you don't know what all the convergence is, but 2 years later, I actually heard people saying it, using this expression. I have no way to know, causality being what it is, whether that literally started with me or if some other simultaneously brilliant people did the very same thing around the same time. But I do know that I stretched it out of my brains, launched it out into the ether, cast my bread upon the waters. After many days, it came back to me. And I'd like to just start that. I don't remember what it was, Gabe, honestly. I know that's a cop out, but I really don't remember it. I don't remember it. Yeah, I am, I am famous, Braden, and I do accept it. I'm at peace with that. Okay, but anyway, can we just do the V? Can we just be called the V? Let's start it. Start it in the CS building. It's the V. That's our nickname as a school. I think it should be the V. In keeping with, we're the largest. Okay, guys, we're the largest university in the state of Utah. You understand that? We are the largest with the best colors too. Let's not forget that. Okay. Well, I love the green, man. I really, really love the green. So, and I don't have, no, I can't rep the V right now. Okay, we'll get back to it. Okay, here we go. But do you understand social contract? Okay, let's move. Let's go. All right. So let's start with sign magnitude. We got to start for all of these exercises. We're just going to start by assuming an 8-bit byte. Okay, and we talked about that really briefly. Like, how big is a byte? Yeah, 8 bits. That's convention. But don't get locked into the idea that all bits in groups are in groups of 8, that all bits that we care about come in groups of 8. That is not true at all. Okay. Um, I think I maybe have mentioned that in data communications of a certain type, was it mostly like serial communications? Yeah. Bytes were like 10 bits because you had to have a start bit and a stop bit because these were bits that were being transferred across a wire. So there actually had to be some header bits around the data bits. So your throughput when you measured it had to be divided by 10, not by 8. So, you see what I'm saying? And that's like today, that's modern. Okay, that's not ancient. And I'm sure the data byte is still the 8 bits inside, but it can be anything that's convenient to do. Okay. So we got 8 bits. We already said we've got 256 numbers to work with, right? And unsigned, they go from 0 to 255. But there's 256 different numbers to work with. How are you going to do negatives, right? Well, one approach that I think immediately comes to mind is, well, why don't we just treat like I got 256 numbers to choose from, right? Available to me. What if I just treated half of them as negative numbers and the other half as positive numbers? Right? I mean, that seems reasonable, right? It would be goofy to have like, well, there are only 5 negative numbers, then all the rest are positive. It would be like, why don't we just say half of them are positive and half of them are negative? Totally reasonable, right? The question is how you're going to do it. And by the way, that idea of I got to have negative numbers, so why don't we have like half the numbers be positive, half the numbers be negative, right? And I'm basically walking you through the creation of the social contract. Like, where did it come from? And that, as opposed to just be like, okay, bullet point number 79, here's what it is, memorize it. If you can remember kind of where this comes from, I think it's a lot more memorable. It sticks in the head a little bit better if you know kind of why this was even a thing. But you got to basically split them up. You know that that's a thing. How are you going to do it? That's the burning question, okay? So, and if we were in class and we could do this faster and be asking these questions, what would be the approach? So one approach, and it's fairly obvious, is, well, why don't we just dedicate 1 bit to being the sign? Eh? Think about it, right? What do we got, Cody? Um, yeah, fair question, Cody. The reason that it's 256 is because we have 8 bits. How many values are there? There are 256 values if you have 8 bits with which to represent them. Cool? Does that make sense, Cody? And that's what we talked about, that whole like 2 to the n, and then when n is 8, 2 to the 8th, right? Which gets us 256. Is that right? Or is that 2 to the, what is it? It's 2 to the 5th is 32, 6th is 64, 7's 128, 8 is 256. There you go. I always do it, right? I always remember 2 to the 5th is 32 because 3 plus 2 is 5. For what that always stuck for me. I always do that, and then I just like tally back up, be completely confident, right? So I don't get that one off, that one off problem. Okay, fair enough. Um, so what if we just dedicate one bit to the sign? Does that make sense? Right? Because things are positive or negative. Isn't that discrete? Isn't that discrete? And isn't that also one of two values? I could be positive or I could be negative. Cool, cool, cool. Um, so it sets up very nicely. I can just take a bit that can be either on or off, and I'll have one of those values either on or off be positive. The other one will represent negative. Okay. Now, if I do that, how many bits does that leave for magnitude? Okay. Magnitude being independent of sign. If I say negative 3,000, what's the magnitude? 3,000. What's the actual number? Negative 3,000. Like it's 3,000 in your overdraft. And you're like, whoa, how do you get an overdraft value that big? Okay. The answer is be employed and become old like me. Right? But the magnitude is 3,000, whether it's positive or negative. Okay. How many bits? So I got 8 bits, and I decide to take one of those bits. I don't care which one, but how many bits does that leave me for magnitude? Right? Well, I just wasted one. It leaves me 7. So I've got 7 bits I can use for magnitude. Now, quick interlude. We dedicated one bit to be positive or negative. One's going to be one, zero's going to be. Which one do you choose? What's your reasoning? Which one would you choose? Josh, is that a typo when you said 0128? Okay, yeah, edit. Yeah. Um, but they're both positive, Josh. So that doesn't make sense. Negative, thank you. You can also edit that back. um, okay, Cody says one is positive. Okay, there's only one other position to take, which would be n is negative. Anybody voting? And Derby's going farthest to the left, which we're not even talking about where for now, but we're gonna go there, Derby, okay? Yeah, Josh says 0 is positive. Spencer says 1 is negative. So Josh and Spencer agree. Um, who is Junelin says 0 negative, 1 positive. Okay, we're split pretty equally. And the question is, does it matter? And it turns out from an implementation perspective, it actually does. And there's one of them that is easier and the other one is harder. So we're going to do the one that's easier to implement. Okay. Now, and Josh said, I think 0 is positive. I'm not talking about what is, I'm talking about what would you do? If you didn't know, which most of you don't, not saying memorize the right answer. I'm saying, what would you do and why, right? Okay. Now think about this. And then, of course, then Derby already asked and, dropped into this one. Which one, and we're going to come back to this, which one would you use? The high order, which is the furthest to the left, that's my left, or the lowest order, which is the furthest to the right? Which one would you use? You can use either one. And I think, Josh up above was actually putting a 0 right on the far right of a set. So you were kind of like, Josh was kind of like, uh, you know, prioritizing to being the sign bit on the right. Um, and Cody says low order. So we got 2 votes for right. Any votes for left? Oh, we got, yeah, Derby said farthest to left. So again, we're kind of split, right? But you understand that when this was all being created in the first place, these were the debates that were actually happening, right? You had to have this debate. Like, it's not like it was like handed down, from on high, or consult the oracle who will tell us the answers. No, no, we had to create this. By we, I mean a generation or two ahead of me had to go through all this, right? Josh says left. We're kind of split. Okay, that's fair. Totally fair. There are rationale behind each one. Okay, here we go. Here we go. Now a quick interlude because I've mentioned this, but I want to be really clear. High order bits are on the left. Low order bits are on the right. They're called low order bits because the bits are worth less. Right? The furthest right bit is worth 1. The next one's worth 2. The next one's worth 4. You give me 64 bits all the way to the left, right? And that thing is worth 2 to the 63rd, right? So the further, just like with numbers in our base 10, right? If somebody gave you a check, for 22 $2,892. And they said, you can bump any one of those four numbers up one. Which one would you bump? You're going to bump the leftmost one because it's worth the most. Bump the leftmost one, you gain $1,000. Bump the next one, you would gain $100. The second to the last, you get $10. Bump the very last one, you got $1, and you really got to go back and restudy some of this algebra and number theory. Okay, but that's why we call it high order bit and low order bit. Okay, that's why we do it. All right, and then this also in the slides, just as a reminder to you that this is the example I was just talking about. Okay, here's how we do it with sign magnitude, and then noodle a little bit about why this actually makes sense. Okay, here's this is, is this the correct answer? It's the sign magnitude answer. Okay, it's the social contract that we decided with respect to sign magnitude. We said that we would use the high order bit, the leftmost bit, that 0 would be positive and 1 would be negative. We decided that. And then the other low order bits would just be the magnitude. Cool? Savvy? What do you think? And drop your comments. Any thoughts here about like why does that make sense? Why does that make some sense? Yeah, just drop your comments while I keep going, and I'm just curious what your thinking is. Okay, right. So here, for example, now this isn't up there, but what if the number's all zeros, right? Or if it's like all zeros and then a 1, it's like right. Who said it? Who said it? Cody said positive is the default. Yeah, if you don't say anything, it's just positive. In other words, when it's a positive number, you treat it exactly the same like as an unsigned integer. As long as the leftmost bit is a 0, right? You just treat it like an unsigned integer. And easy peasy, as we say. But yes, Bryce, yes, you are restricted to only, no, you're not restricted to 256 times 2. What are you actually restricted to, Bryce? You are restricted because you've got 8 bits to work with. One of the bits has gone away. That's right, you're restricted to 128 numbers of one type and 128 numbers of another type. So you are restricted to that. That's right. And that's why, as soon as you have to like stick one number and say that's the sign bit, that's when you're constrained. You got like an upper bound on the number of bits. You could say, well, put the sign bit on the right, and then you're not constrained. For sign magnitude, that actually would be smart. That there's a certain smartness to that. Has some other problems, but that kind of makes sense to overcome that one problem, right? So, right now, Alex, this is the thing. We're going to talk about what is the actual range, okay? But let's start with what Alex said. In a kind of a ballpark way, you're right. But I'm going to do it this way. I'm going to say you've got approximately negative 128 and approximately positive 128, right? But that's sort of the intuition. I got 256 values. I'm going to put half of them in the positive bucket. I'm going to put half of them in the negative bucket. Okay. So broadly speaking, you're right on. In terms of like detail, you're wrong, but oh so minutely wrong and so close. Okay. That's where we're going to get. Yeah. So, right. So Texas goes, base 10, we denote a negative number with right. We just put a minus sign. That's it. And before the magnitude, the same could also go with base 2, but the only difference is a leading 0 or 1 could denote. And that is exactly what sign magnitude is. Okay? That is exactly what sign magnitude is. Okay? That's your negative, that's your positive sign or no sign. And that's your magnitude. That's it. And if I flipped, do I have the coolest slide of the ages? Yeah, right there. if I flip the sign, it's just like I took this number 108. And if you do the math at home, right? No ones, no twos. I got a 4, I got an 8, that's 12. No 16s, I got a 32. So that's 44, right? And then I tack on 64, I get 108. And it's positive, which means it's like there's no sign, right? And then if I just walk up, you write 108 on a piece of paper, and I walk up and go and put a minus sign, right? What happens? Over in our decimal world, it looks like what's on the right. In sign magnitude world, it does what's on the left, right? Positive sign, negative sign. You see how the magnitude never changes? Magnitude is what it is. Minus sign just goes to negative or positive. That's it. That's sign magnitude. Okay? Everybody cool? Let me see. So because binary is base 2, which it is 2's complement. No, 2's complement, we haven't talked about it, and that is not what it is. That is not what it is, Joshua. Scrub that idea out of your head. Okay? Scrub it all the way out. We're gonna tell you, I'm gonna tell you what 2's complement notation is. Okay? All right. Now we're still talking about sign magnitude. What's the range? So we had a stake in the sand. Who said it? Alex put a stake in the sand, and Alex gets the guts award, gets the courage award so far for class by just putting a stake in the sand. And it's not right on, but the intuition is dead on. Okay, the intuition is solid, Alex, but the finesse is not quite there. But that's what we're going to do right now. What's the range of possible values? Okay, well, there we go. We did this before, right? With unsigned, we did this. Like that was the smallest value, right? And you're like, oh, so the range of values is from 0 to negative 127. And you're like, wait, that doesn't even make sense. That's not our range of values, okay? Also notice right here. So this relates kind of back to Alex's comment, right? It's a negative number. What's the magnitude? 7 ones is the magnitude. What is 7 ones? 127. Because 1 plus 2 plus 4 plus 8, right? Same drill. You add them up, it's 127. So that's like, no, that's not the right way to think about it. Not the right way to think about it with sign magnitude. So the way we were thinking about it with unsigned, not applicable here anymore. Okay? Let's try this again. What if we say, let's look at the positive numbers first, which goes from all zeros to 0 with the largest magnitude. Right on? From 0 to 127. Now, if I wanted to be really persnickety, what number is this on the left really? Really, truly? Anybody want to lob a guess? Yeah, it's no, not negative, Alex. Positive 0, not 0 plus. Come on, Matthew. Positive 0, plus 0 or positive 0. Yeah, right. That's technically what that is. But we're just going to go 0. That's okay. Okay. So we look at the positive numbers, which goes from 0 to 127. Any guesses about what the negative numbers are going to be? All we're going to do is flip the sign bit. That's going to be, you know it's coming. That's going to be from negative 0 to negative 127. Yep. In sign magnitude, there are 2 zeros. There's positive 0 and there's negative 0. For one thing, it's a wasted number. It's a wasted value. Like, I don't really need both positive 0 and negative 0, right? I don't really need that. But it's built into the system, right? Because once I have a bit and the bit, see, when we're doing this in our normal, Arabic numerals, that like we do our normal base 10 stuff, right? We, if it's positive, we don't say anything. When it's a negative, we add the negative sign. Well, with a sign bit, that bit has to be one of the 2 values at all times. Has to be. So if it's a 0, it's positive. It's a 1, it's negative. By the way, another way to remember which one it is, just think about the fact that the 0, there's nothing there kind of, and the 1, it's kind of like a minus sign on its side, like a minus side, minus sign stood up. That might help you just to carve into your head this idea that, that the 1 on the left is kind of like a minus sign. Okay, to remind you. Yes, that's right. So Bryce, when they say that, 0, that's right. Depends on how old your kids are, Bryce. Yeah, Cody, you have been lied to your entire life. And by the way, almost anything really does depend. I mean, again, it's social contract, right? There was a big debate, I think, during this summer of discontent about whether 2 plus 2 could be something other than 4. It's also a famous line from 1984, the novel, which I highly recommend, especially these days. And that was one of the tests that Big Brother would apply, whether you could admit that 2 plus 2 could be 5, right? But the reality is that it is really dependent upon social, not to be overly pedantic, but the actual answer does depend on the social contract. If you're saying this is integer arithmetic, then it's bloody 4, okay? Then 2 plus 2 is freaking 4 if the social contract is integer arithmetic, integer addition. So the real question is, what do those values represent, and what is the definition of the operator, and what's the social contract to define the contrast, or to define the context? Okay, that is the actual, accurate, nuanced answer to that question. And by the way, my kingdom for some nuance in social and political conversation. Can we please get some effing nuance into the system? You know what I mean? So if somebody comes to me and goes, so 2 plus 2, can it be 2 plus 2? What is it? And I will say, well, if your assumption is that this is integer addition, then I already know what the two values represent, and I know how that operator works, and the answer is 4. If that's not the case, you need to define for me what the social contract is. So I know what is represented by the items, by the numbers. What do they represent? And they don't even have to represent the same kind of thing, right? Like, for example, in my world, one grandson plus one grandson equals carnage and terror and screaming and maybe blood. That's my experience, right? Okay, is that 4 or 5? I don't know. Different social context, right? Speaking of my grandchildren, who I love, but you know what I'm trying to say? It's a social contract. It means whatever we say it means, but you don't just get to change it willy-nilly, nor do you get to use the phrase willy-nilly unless you're at least 60 years old, okay? So don't you dare use willy-nilly walking around at your age. Okay, that's a bit of a departure. That's a bit of a departure from the lecture. But do you understand what I'm trying to say? I'm trying to reinforce social contract. You have to tell me. So again, if somebody wants to play that stupid political trick, um, um, now whether saying that the only solution is 4 is okay. I'm going to disagree with this no person. Yeah, okay. Both Hari and no lack nuance. Let me just say that they're both wrong, in my opinion. They're both wrong, and they both lack nuance. And neither of them is actually getting down to the actual gist of the issue. If somebody tells you that it is integer addition and the answer is 5, okay, now they're messing with you. Okay, now they're detached from reality. So I'll grant you have that, but you have got to state the assumptions before you tell me what the answer can be. Okay? And in my world of sign magnitude, you bet there's a -0. Damn right there's a -0 in this world of sign magnitude. Okay? All right, let's move on. Is this interesting? This little mind blow maybe equips you to move toward nuance in this entire madness that we're all living through right now. Nuance. Nuance. And Junelin, 2 plus 2 does equal fish under certain contexts. Absolutely. I have no question at all about that. Okay. No hesitation. And fish plus fish could equal more fish, Matthew, or it could equal less fish. I have a homicidal, ichthyocidal, cannibalistic beta fish. And I will tell you that fish plus fish equals one fish. But my fish is Jeffrey Dahmer. So that, is it too soon? Is it too soon? Probably. You know what I'm trying to say? Again, right? It's social contract. Okay. All right. There we go. Let's go. Let's go. So that's our actual range. Our actual range is from negative 127 to positive 127. Okay. How many values are there? You should know this real quick. Shouldn't be really difficult given everything we've talked about. That's a beta fish, man. They are brutal. The beta fish, man. Oh, when this beta fish dies, I'm giving him a Christian burial via garbage disposal, and I'm out. And I'm done. I'm done with beta fish. Okay. Okay. Derby says 255. Bryce says 256. Yeah, they are Siamese fighting fish. Absolutely. Okay. Derby and Bryce are both correct. And this is a question on the exam always. What's the range of sign magnitude values? If I have 8-bit sign magnitude values, the range is from negative 127 to positive 127. How many values are there? There's 256 if you consider 0 and negative 0 to be different numbers, which literally they are. Conceptually, I don't know. So if you say 255 because you assume that 0 and negative 0 are the same value, also correct. I will take either of those two answers, okay? Cool? And you got to admit, this philosophy crap is way more fun than binary. Let's be honest, okay? Drop into 305G if you want to party. If you want, Dr. K's fever dream, that's 305G. It is a blast, and we're having a good time. Okay. Hit me next semester on 305G. All right. So here's the thing, and I don't want to belabor this too much, but it ought to occur to you by now that you could literally use any rando pattern of anything and have it mean whatever you want. And that is true. It's correct. But the thing is, the simpler we can make it, right, the simpler the hardware becomes. You've got to still implement this in hardware. You still got to build an adder, you still got to do that stuff. Yeah, man. Yeah, Cody, I'm right with you. Okay. All right, here we go. Now another interlude, counting in binary. You've got to be able to count in binary. It becomes foundational for everything else we're about to talk about. Okay. Now you think about counting. What is counting really? Think about base 10, right? We're back to our Arabic numbers, our numerals, and we're decimal, and we're base 10. When I say, okay, start counting from 1, right? And I go 1, 2, 3, 4, or like they're gonna probably do to me tomorrow when they put me on whatever they put in my drip, and they're gonna go, okay, count backwards from 100. And you're like, hey, you're just doing this to mock me. You're like, 90, that's how that goes. But what am I doing? When I count, what am I doing? I am just adding 1. I'm adding 1. When I count backwards from 100, 99, 98, I'm just subtracting 1 every time. That's all counting is adding 1. So the act of adding 1 and the act of counting are the same act. Okay? Fundamentally the same. I should count in binary. Nice. Count backwards from 100. I gotta start with working that out in my mind first. Okay, here's how it goes. Now, what do you do when you're in decimal and I say 19 plus 1? What happens? Well, the 9 and the 1 make 10. There's no tens digit. I have to go 0 and I've got to carry the 1, right? And then I go like 1 plus 1, that gives me 2, and I get 29. If it were 99 and I counted up, the next number is 100, we know that. But it's 9 plus 1 gives me 0, carry the 1. 9 plus 1, right? Plus 0 is 10. Again, 0, carry the 1. There's nothing, so the 1 just comes down. 100, okay? You carry the 1. Same thing happens in binary, okay? Check it out. I add 1 to that. When I add 1 to that, I get 0, carry the 1. Also note that that's the 2 right there. Now I add 1, right? No carry. It's just 1, 1. Note that that's 3, 2 plus 1. I add 1. Now it's going to ripple. I got to add 1. I'm going to get 0, carry the 1. 1 and 1 is going to give me 0, carry the 1. And I'm going to have this number 1, 0, 0, which is also 4. And you can see that as we count, they align. Okay? Do it again, I get 5. Do it again, I get 6. Blah, 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 etc. Ad infinitum. Okay? And the digits ripple to the left as part of the carry. All right, everybody cool with that? That's counting in binary. So let's do some binary addition. Okay? Check it out. What are we going to do? 1 plus 0 is 1. 1 plus 0, 1. 0 plus 1, 1. Okay, 1 plus 1, that's 0, carry the 1. Boom, there's the 1 that we carried. Okay, now does anybody just freak out? No, the answer's 3. 1 plus 1 plus 1. Yeah, the answer actually is 3. What is 3 in binary? I'll give you a hint. Victory. That's 3 in binary, right? Well, what's the answer? 1, carry the 1. That's it right there. 1 plus 1 gives me 0, carry the 1. 1 plus 0 gives me 1. And 0 plus 0 gives me 0. There we go. Boom. Binary addition. You just did binary addition. And for those of you that are like, what about subtraction? I'm going to be like, silence. We will get to it. Okay. Now, turns out, and you can, by the way, you can also validate this yourself. You know what I mean? I should have this over there, really. You know what I mean? But this is how you validate it. You just look at the top number and like, okay, I got a 1, I got a 2, 4, 8, 16. So 16 plus 8, 24, plus 2 is 26, plus 1 is 27. Remember 27. And then this one is no ones, no twos. I got 4, 8, 16, 32. 32 and 16 is 48. Plus 8 is 56. Plus 4 is 60. 60 plus 27 is 87. Am I doing it? Stop me if I'm blowing this in my head. Okay, what did we just say? 87? Okay, let's go. I got 1s, 2s, 4s, 8s, 16, 32, 64s. So I got 64 plus 16 is 80. And immediately you should start to go, oh, that's 7 right there. I already know that one. 4 plus 2 plus 1, 87. Boom. So you can double check it. It's like a checksum. You can validate it, you know? That's the right way to go on that. Just validate it. Double check it. Cool. All right. I'm excited. I know you are. So it turns out that it's way easier to build circuitry. Remember, we're in sign magnitude world now. Okay. And by the way, this one right here, do we care at this point whether that's a sign magnitude number or an unsigned number? Is there any difference as far as we're concerned? At this point, just looking at it. What I mean by that is, does the answer change? Does it affect the answer? What say you? Are we still responding to Junlin? Let me see. So which part? So Junlin, which part? Let me see. Why did you carry the 1 and leave a 0 when there were 2 1s? Because 1 plus 1 is 0, carry the 1. 1 plus 1 is 1, 0. Put another way, 1 plus 1 is 2. The representation for 2, 1, 0. 1 plus 1 is 0, carry the 1. Work that, Junlin, you gotta crank that one through, okay? You gotta work that in your head until in the mysterious hypnosis of Dr. K, it actually like clicks and seems to make sense. When that makes sense, you are being assimilated into binary and you will feel some disorientation at first. and then you will feel a peaceful euphoria that will wash over you. Okay. You have to just like do it until it clicks. It's all you got. It's really just all you got. But that's the logic. And if you look at that, it takes a little while to click. Okay. And I'm going to keep moving, but this is good. And thanks for everybody jumping in as well. Again, I love that. Love jumping in to try to help each other. It turns out that if I have circuitry, I'm building circuitry, and if I can take a positive number and its the representation of a negative number that's the same magnitude, okay? Positive 10 and negative 10, positive 128 and negative 128, right? Whatever. If I can take a positive number and a negative number of the same magnitude, okay? And if I can add those together and the answer pops out 0, that's a really good thing, okay? That really makes a crap ton of circuitry easier to build, to design, to implement, everything, okay? Now, let's take a look. Let's try it. Let's try sign magnitude, because that's what we've learned so far. Unsigned, it doesn't even make sense. We can't even have this conversation in unsigned, because there's no negative number in unsigned notation. Sign magnitude notation. Let's take a look. That's plus 43, and that's negative 43, right? Everybody buying? You can work it yourself. Again, 1, 2, 4, 8, 16, 32, plus 8 is 40, plus 2 is 42, plus 1 is 43. Boom. And then negative is just flip that sign bit. Now we're going to do the arithmetic thing. Add them together. Now we're not going to walk through it, but just real quickly, that's the answer. 1 plus 1 is 0, carry the 1. 1 and 1 and 1 is 1, carry the 1. The 1 drops down, right? 1 and 1 is 0, carry the 1. 1 drops down. 1 and 1 is 0, carry the 1. The 1 drops down. Well, guess what, my friends? That is not 0. It's not 0 in anything unless you create a new system in which that's 0. But that's not 0 in sign magnitude. So that didn't work out really well. Okay. So not superbly bueno. What do we do? What do we do? And you're welcome, Julian, and also everybody that jumped in. That's crazy, crazy helpful. Again, I love the collaboration and the help, that you give each other. It's fabulous. Okay. So they then went about to like, okay, we got to fix this thing, and we're running short on time. But I'm gonna get right up to 2's complement, and I'm gonna pause, and then later today, you know what I really ought to do? I ought to do at least one of these. Like I got to grab something to eat right after this, and then like in a half hour, I'll just drop back in. You know what I mean? As soon as I can get back to it, I'll just drop back in and keep going for another hour and 15 minutes. Then if I've got time before my 4 o'clock class or later on, I can do another one. Let's do that. So if anybody wants to like, you just like, can't get enough of the Dr. K show, then you're like, I got to give me some more of this. Be back in like a half an hour, and I'll post on the general chat. Okay. On the general text. Okay. And let's see. So yeah, Josh, I'm not sure what the question means either. I'm kind of with Matthew on that as well. Josh, if you can clarify, that would be great. Let me see. Oh, you could say, yeah, four periods of Dr. K in one day. Three. Oh, Josh, great question. Will you ever have like 4 ones stacked up? And the answer is, as long as you're adding 2 numbers, no, it's not possible, right? Does that make sense? It will never happen, because the biggest numbers you could ever add together is a 1 and a 1, and the answer is 1, carry the 1. And if that next column was 1 and 1, you'd have 1, 1, 1. It says it's the biggest number you can get.
What's this?
This is a class.
Hot mic.
That you took lessons?
Waco, hot mic. Hey, Waco's not paying attention. Okay, I'm muting Waco because it was starting to sound like awkward or something.
Sounds like she was just waking up.
That could be. And I respect
No
that.
offense.
I respect, I just don't know, right? I don't want to stick around long enough to know. And I do respect the whole 12:45 wake up thing. Okay, we're going to hit one's complement and then I'm going to stop until we come back. So what they did was they said, hey, what would happen if we just took like um, just a sign magnitude representation of a positive number, or really for that matter, which is the same as an unsigned notation, right? Unsigned integer. And what if we just said, okay, to make a negative number, we're just going to flip all the bits, right? Like somebody was like, hey, that sign bit with sign magnitude, we took the 0 as a sign bit, right? And we just flipped it. Oh, boom, negative sign. Well, what if we just flipped everything else and just said, that's the negative right there. That's the negative. And if I want to negate that, right, I flip all the bits. I got the positive version. I want to negate that. I flip all the bits. I got the negative version, right? That seems like then what happens? That was kind of where this came from. So you'd get that as positive, whatever that is, which I don't want to do the math off real quick. It's probably right there. Oh, it's positive 83. And that would be negative 83. And it was called one's complement because it's not like complementary in the sense of your hair looks really, really good today. It's complement in that other spelling that means uh, the the balance. I can't define complement off the top of my head, but it's like the opposite, or like I don't know, right? Somebody drop me a definition of complement or complementary. Um, uh, anyway, that was the idea. You just flip all the bits so that ones turn into zeros, zeros turn into one. You're going to make it whatever the complement of it was. That was why the notation. Okay. Now that's cool, but let's try it. Let's try the secret, right? We took the 43, flipped all the bits to get this number right there, negative 43, right? Remember, it's really, really helpful if we can add a positive number to a negative number of the same magnitude, right? Two numbers that are negations of each other. If we can add them together and get a 0, that's really, really helpful. Okay, let's try it. You already can see what we're going to get, right? And we're going to get a negative 127. Nope, nope. So close, not 0, not 0. But here's the tricky question. And this is where they went. And there were machines built that did one's complement notation. Okay, so all the integers were in one's complement notation. They had to build fancy things into the addition and stuff like that. But if I wanted to turn that into a 0, what would I have to do? There's two things that I have to do that are both very tiny steps that I could do to that to make that value, negative 127, into a 0. What would I do? Let's go, Bueller. I would add 1. And what's the second thing I have to do that's very important? And this is a little less obvious and maybe it doesn't occur immediately. And I'm just going to blurt it out because we're out of time. Right. And really, I think where you're going with, that's right. Matthew said take the highest order digit out. Um, and no, not keep the sign bit, actually, Matt. And Texas, by carry the last digit, means really let the carry just go away. Don't worry about it. It's like ignore the carry out. Like that when it wants to overflow into the ninth bit, if you would just ignore that, you have 0. Do I have a slide? No, I don't have a slide, but this is good enough. Okay. If I added 1, 1 and 1 is 0, carry the 1, it would just go flippity flip, 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 all the way. Everything turns into zeros for 8 bits worth. And then the last bit just like tosses itself over the ledge, and we don't, as long as we don't care about it, this works and we turn it into 0. That idea got people thinking like, well, okay, flip all the bits and add 1 to the answer, right? Add complementary numbers. And as long as we add 1 when we're done, it'll kind of come out okay. And someone just said, well, what would happen if we just added 1 as part of the notation? Like every time we took the positive number, all clean, and whenever we wanted to negate it, what if we flipped all the bits and added 1 right then? What would happen? And you know what happened? two's complement notation was birthed right there. And that is the standard. That is the gold standard today for signed integers and the notation that is used in pretty much, not all, probably, maybe, but any that I know of, two's complement notation, which has to do with how we look at integers under this new social contract. And that is a teaser. That's the spoiler. What have I got to show you on the way out? I'm walking out of here. I'm going to show you a pixie bub made by my daughter Brooke, who does these professionally, modeled after me as a Pharisee in season 2 of The Chosen. Literally modeled after me, including the beard. This was custom made for me, my friends, and it's a pixie bub, and it makes my heart go warm. So that's
It's
my
adorable.
isn't that adorable? And Brooke makes these like custom. You can actually go check her out on Instagram, Pixie Bubs, and see her stuff. It's frickin' I'm not promoting, right? But it's frickin' genius. It just this is just my little bit of emotional sharing for today. Pixie Bub, this is the Pharisee Bub, literally modeled after a picture of me taken on set of season 2 of The Chosen, which was filmed in Utah this last fall. Alrighty, I'm out. That's it. Pixie Bub and me, we're going to hang tight, get something to eat, and be back in like a half hour. Go again. I will drop notifications in the text channel. If you can't make it, it's seriously no problem. But
Hey,
if you can,
thank you.
that'd be good. All right. You're welcome, everybody.
Thanks, Dr. K.
You're welcome.
Hey there.
Oh, hey, Zach. I'm going to shut down my stream so you can say things off the record.
That's probably best, yeah.
It's probably for the best.
You never know what I'll say next.